it's already
Yes.
quite late
No
in
problem.
Melbourne. Yeah, so appreciate that you are spending your time and effort to give a seminar to BINU students this evening. So again, welcome everyone to this today's seminar. We are very honored today to have Dr. Jonathan Hua from Deakin University together here with us today. And Dr. Hua will be giving a seminar or a short talk with the title of At the Intersection of Internet of Things and Big Data. So I think before we start, it's good to for me to introduce briefly uh, for Dr. Kwa's experiences. So Dr. Jonathan Kwa received his Bachelor of Engineering, first class honors degree in telecommunication and network engineering in 2014 from Swinburne University of Technology in Melbourne. And he also received his PhD degree in telecommunications engineering, also from Swinburne University of Technology in 2019. And he is currently a lecturer in Internet of Things at Deakin University, Australia. So Deakin University is one of our strategic partners from in Australia for the School of Computer Science. And Dr. research interests are in the broad areas of computer systems and data networking, network measurements, adaptive multimedia streaming, data transport protocols, and also bottleneck queue management techniques. He is also interested in emerging communication technologies for the Internet of Things, distributed computing, and also network systems, with an overarching focus of improving the user experience and quality of the service for the Internet. So, Dr. Kwa, together with us today, I see we have Dr. Susan joining with us today. Hello, Dr. Susan.
Hello, Miss Santi. Hello, Professor Jonathan Kwa.
Hello, hi, Susan. Good to see you again.
Yes, thank you for joining. So, and we also have around 436 students joining us today. Most of them are in their last year of study, and I think most of them are also doing their internships. That is why we kindly request for the seminar to be conducted quite late at night. So thank you again for that. I think so. Without further ado, Dr. Kwa, because we don't want to spend your time any longer, the time is yours. Thank you.
All right. Thank you very much, Santi. Thanks for the kind introduction. And it's a great pleasure to be able to present a guest lecture today to students at BINUS. I really appreciate you taking the time as well to listen into this lecture, especially after a long day of work. Hopefully you're all keeping safe and well. This pandemic has really affected all of us, and Melbourne today just announced an extended lockdown. So I think we are all affected in some way or another. But really appreciate this opportunity and think Zoom is a great platform to be able to meet you all. So I'm happy to interact with you after this session. If you have any questions throughout the presentation, please feel free to let me know. So I'll just present my slides. See my slides okay? Yeah. All right. So basically today's lecture, it's an overview lecture of Internet of Things and Big Data. So we heard about Internet of Things, we hear about cloud computing, big data, AI, machine learning, all of these buzzwords in IT now, which is very topical. But what we actually want to do is we want to give you a good overview of what Internet of Things is and what big data is and how two of them are related. Right. So, and it's more from an application perspective. So a lot of you are doing your internship in your final year. You'll be going to the workforce very soon. And a lot of these really give you a sort of foundation of what it's like in the workforce in terms of an application. So not too many theories, mathematical equations, all of that, but more from an application perspective. So I hope you find this interesting. So it basically gives you an overview of the ecosystem in IoT and big data. So a few key points here, what we're going to talk about today. It's basically the question, what is IoT, right? So what is the Internet of Things? What really is the Internet of Things? And what things are we talking about here? Why do we need IoT? Right? We have the Internet now. Like, why do we need IoT? We have computers, we have smartphones. What is IoT and why do we need IoT? And big data, right? What is big data? Is it just a lot of data? Is it just many types of data? And why do we need big data and big data analytics, right? And what is its relationship with IoT? And finally, I'll give you an overview of IoT architecture, of how data analytics and IoT relate, and how we can build an architecture with IoT and big data, right? So which is implemented in a lot of tech companies and a lot of solutions. And you might find this interesting while you're doing your internship. And throughout this talk, if you find some parts which you relate to in your workforce or in your internship, that you might be working on some prototype or some solutions, yeah, feel free to share. We'll be interested to hear from you too. So to set a scene, in introduction of IoT. So before we talk about the Internet of Things, we need to understand the Internet, right? So we all use the Internet. The Internet is part and parcel of everyday lives. We need to understand what the Internet is and how it affects our lives and how it all works, right? Before understanding the Internet of Things. So on the right-hand side, you can see this visualization picture here. It's actually a visualization of the nodes on the Internet right now. This was taken a couple of years back, and you can see how complex it is, right? So many, many millions of loosely cooperating, mostly decoupled devices communicating with each other, right? So right now at this time, I'm using Zoom in Melbourne, you're in Indonesia. We all are connected via Zoom service over the Internet and via different devices, right? It could be a tablet, a smartphone, a laptop, a full desktop, right? So all of these different types of devices interacting with each other on the Internet, going through multiple paths, multiple routes, different routing information, etc. So as you can see, it's very, very complex. But now the Internet, it's amazing in the way that it works, right? No one owns the Internet, right? Who owns the Internet? There's no one country, one organization that manages the Internet, right? So it's amazing that this huge network of networks actually work and cooperate, and somehow it's optimized, right, for speed, responsiveness, consistency, quality. And it is surprising that the Internet works at all. It doesn't break, right? For the past 18 months with pandemic, a lot of this network traffic has dramatically increased and moved from enterprise networks to residential networks, right? Because a lot of us are studying from home, working from home, teaching from home, and in our downtime, you watch Netflix, YouTube, streaming, right? Music. So all of these traffic that sort of gets moved to the residential networks becomes quite a big thing. But the Internet was able to self-organize and optimize to cater for this need. Of course, you have ISPs putting in extra bandwidth, extra capacity to ease the burden. But just to give you an idea of how complex the Internet actually is in this day and age, and it is quite interesting if that's your interest to really look into how Internet is built and how we actually cooperate and work. So all of these standards that sort of govern the Internet today. So why do we talk a lot about the Internet, right? Because when people hear the Internet of Things, you see the word Internet there, they immediately think of the Internet, right? So is the Internet of Things merely just something that communicates over the Internet? Some years back, when the Internet of Things first became like a hot topic, a lot of people say it's just a hype, right? It's just devices connected to the Internet. But that's actually not the case. So the Internet of Things is not merely devices communicating over the internet, it also means devices talking to each other, right? It doesn't necessarily have to go through the internet. So if you have two nodes, a sensor and a gateway, both of them communicate. That's part of Internet of Things, right? So if you have a smart camera at home, like a CCTV, and you have a gateway, you build your own server at home. You don't forward that information to the internet. That's also part of Internet of Things, right? So as you can see here in this picture, you have very diverse, heterogeneous type of devices. So smartphones, tablets are the obvious ones, PC are the obvious ones, but you have things like refrigerator, right? Smart fridge, smart TV, smart oven, right? CCTV, locks, right? Talking to the internet, right? Smart plug, bulbs, and all of that. Light bulbs talking to the internet. So all of these becomes part of the Internet of Things. Right? And on the right-hand side, you can see this smart city concept where buildings are equipped with sensors, temperature sensors, humidity sensors, and all of these different sensors to facilitate the smart cities or smart anything, really. And this concept of smart became really popular over the past decade. So you hear things about smart cities, smart homes, smart factories, smart vehicles. You can almost say smart anything now when you have sensors connected to it, right? So in 2020, more than 50 billion devices were connected, right? So 50 billion. So how many is 50 billion, right? So that's about 8 devices per person. And that's reasonable, right? So if you look around you, how many devices do you have? So you have your tablet, you have your smartphone, maybe Fitbit, then you have your PC, laptop, at least a few sort of smart gadgets around you. But a lot of people now go to these smart concepts where they use everything to track their movements, right? So a lot of these smart devices are available to regular consumer. So you don't have to pay a lot to get these smart applications today. The impact on economy it's massive. So on automotive, it's 202 billion, and healthcare 69 billion, consumer electronics 445 billion, utilities 36 billion, etc. And all of these are in US dollars, right? So the impact on global economy it's huge with smart concepts, right? And you have probably heard of the term Industry 4.0, industrial IoT, where a lot of this machinery are communicating with each other in an automatic fashion, right? So all this production line are being optimized with robots, automated pipeline, right? So production line are all be automated with Internet of Things. And industrial IoT, it's another topic, right? It's it's a subset of IoT, but it's a more specialized form of IoT in that it has very specific purpose in its design. Right. So on this diagram there, you can see the sort of the growth of smart devices or internet connected devices growing, right, in the past 10, 15 years, and it's exceeding 50 billion devices now. And in the next 10 years, one can only imagine how much it can grow. So a brief history of IoT. So how the IoT came about. Right. So why all of a sudden IoT exploded? Right? Why no one heard of IoT before, like 10 or 15 years ago? So we'll probably just get used to the internet, right? Browsing the web, etc. But what is IoT? So IoT is actually not new. The concept was there since 1982, right? So that's a long time ago. I mean, in a technological perspective, that's a long time, right? So the Network of Things as a concept in 1982, then you have the Internet of Things in 1999, and the Internet of Things as we know of today actually was conceptualized in 2014, right? So that's why people say like it's relatively new, because in 2014, that's when Cisco proposed that overarching idea of Internet of Everything, Internet of Things, with really nice advertisement, nice video about how all of these smart devices operate, right? But the concept itself, it's actually there for the past 30 years. So the first article that was proposed in 2004 is called Internet Zero. So Internet Zero proposed a general purpose low speed physical layer to route IP over anything, right? So as we all know, IP is the narrow ways of the OSI model. So if you're familiar with the computer networking model, you have the physical layer, the data link layer, the network layer, transport layer, then the application layer, and IP is basically the narrow ways of this whole thing at the network layer. Everything runs above IP, and all the technology also sort of innovates below IP, right? So IP is the layer that sort of glues everything together, and Internet Zero is the idea where you have not just computers, right? You have all of these devices can send and receive information with packets over the IP protocol, the Internet protocol. So that's the idea that was first published in 2004. So how did the term Internet of Things came about, right? So you have Network of Things, Intranet of Things, Internet of Things. So if you are interested, you can have a look into this story in 1999. Kevin Ashton, right? He actually was in a rush for a title for his presentation slides at that time. So he's trying to present his work in RFID. Then he just came up with this term called Internet of Things and just put it on his presentation slide for the presentation. And that became the thing, right? And we all use the Internet of Things today. So that's quite interesting story of how the term Internet of Things came about. So the concept became really popular in the Auto ID Center at MIT, and it was driven a lot by industry to build M2M, so machine to machine, machine to human, human to human networks, right? So machine to machine means you have inanimate machine talking to each other, sending, receiving data. Machine to human, it's like us, we interact with machines. Human to human, it's like the internet, right? So I'm communicating with someone over the internet. So that's the different type of networks that was driven by the industry. And 2014, Cisco proposed Internet of Everything, and all of the other tech companies sort of pushed this idea of IoT. That's why it became like a thing over the past less than 10 years. And also, of course, the innovation in communication technology, right? So 4G, 5G coming up that really supports the bandwidth and capacity needed for IoT. So you have these technological advances that supports IoT, and also the need, right? The need for better bandwidth, better services over the internet. So you're probably aware now that Internet of Things is very prevalent in many different applications, right? Transportation, agriculture, buildings and cities, hospitality, visual security, wind farms. So all of the application you can think of, anything that have sensors attached to it that send data, collect data, do something with the data, they're all part of IoT. And you have the cloud. You can see this picture at the top. The cloud is basically data centers, right? So data centers like Google, Microsoft, AWS, right? Processing big amount of data, has very large processing resources that are called on the cloud. So IoT is a giant network of connected things, right? It's basically a whole ecosystem, right? They're interconnected with each other. It can be everyday objects, right, or cloud-hosted services. IoT requires cloud computing, right, to store data, process data, make informed decisions, right? So there's no point of collecting data if we don't make sense of that data, right? You can collect a lot of data with your sensors, but if you don't use that data to make good decisions, then there's no point of collecting this data, right? So you have this paradigm in IoT where you have collected data, then you send it to somewhere to process, right? Usually IoT devices can't process because they are quite low in terms of their processing capacity. So you usually send it to, say, a gateway or PC, or maybe to the cloud, right, to the data center, like Google or Microsoft or AWS. They have huge amount of processing power. Then they sort of crunch this data and basically output a decision or like an insight to the data. Then what do you do with the data? You want to do something about it, right? So depending on what the application is, you want to use that information to make informed decisions. So all of these sensors, right, mobile phones, wearables, sensors in agriculture, in transportation, on the roads, in the city. They generate a lot of data, right? So for example, motion sensors in a smart home transmit data every second, right? So imagine every second you send a data, right, to a database or somewhere to store, and you have lots and lots of sensors to this, and you want to graph them, you want to do something interesting with them, right? So they generate a lot of data, and the number of connecting things keep on increasing, right? So that's the graph there. It's really exceeded the world's population, right? So one person will have 7 to 8 devices on average. So data needs to be stored. We need cloud-based analytics. Another important thing that you're probably aware of as well is the need for real-time processing, right? So there's no point of sending a data somewhere to process. It takes 1 hour or a day to process and return it back to me, because like once the decision is made, the data is basically useless, right? So depending on the application, like autonomous vehicles or even simple application, you want to basically get the data, the decision as quick as possible, right? So the need for real-time processing is very important in many applications. And you can see how much potential there is for diverse devices to become IoT devices, right? So the smart fridge, smart TV, smart shoes, many more appliances, they need to communicate with each other, they share data, right? Another thing is heterogeneity. Heterogeneity basically means we don't use the same model or same devices manufactured by the same company, right? So there's a lot of company out there making different types of devices. So how does device A communicate with device B, right? If they are not part of the same sort of ecosystem. So that's that vast difference in an IoT ecosystem. So you've probably seen a lot of these devices, maybe in your course or in your internship. So things like Arduinos, things like Raspberry Pis, BeagleBoard, and small or large system on chips devices, right? So a lot of these devices are out there, and they're getting cheaper and more programmable, right? So basically, you can write a code to program them and do things that you want, right? So you can buy them off the shelf and then start building your own IoT systems. And a lot of these are off-the-shelf gadgets and tools, right? So, and some of them come with applications, right? Like Fitbit, they come with an app on your mobile phone. They can track your sort of movements and show some analytics with regards to your movements, etc. So a lot of these systems will have some form of mobile application or user interface for people to interact with. So things are connected, right? So you can see home, daily life devices, business, public infrastructure, healthcare. A lot of this has sensors, interfaces, right? Like your cars and sometimes coffee machine too, right? You can see these smart gadgets. Like all of these are actually embedded devices. They are basically mini computers, right? Sitting in this hardware, making decisions and do some form of processing, right? So more and more things are being connected. As much as you can imagine, there's basically IoT sensors and devices in practically everything that we do today. So this is just an illustration here of how IoT sensors capture your movement or capture basically activity and then convert them to signals and transmit to the internet, right? So if you have motion sensors, so athletes do this, right? Professional athletes, they have sensors on their wrists, on their legs, to monitor for their heart rate, their acceleration, and all sorts of athletic performance measures. And they collect these sensors, right? Collect this data. These sensors collect data. Once all of this data gets aggregated and maybe gets sent to a central gateway, right? Or it could be a mobile phone or a database somewhere, and the database either it processes there or most of the time it sends to a offsite cloud infrastructure. So if you use Amazon AWS, then it will send it to an AWS cloud service and do all that storage and processing of that data over the internet, right? So as you can see here, things that are seemingly not important, right? It's not banking details or not personal information. It's really an athletic for performance and data, but it is still quite sensitive, right? So it is still personal information. So there's this thing about security here. How do we ensure security and privacy of sending this data over the internet? Right? Here is another example. So not humans, these are cars, right? So if you heard of autonomous vehicles or even automated connected vehicles, they're actually constantly sending data, right? So you have this thing called V2X, right? So vehicle to everything. So you have vehicle to infrastructure, vehicle to vehicle communication, and all of that really smart sort of interaction between vehicles are really driven by IoT devices, right? So you have sensors being attached to cars, being able to send information to the roadside gateway or to the 3G or 4G tower nearby and to the internet, etc. Right? And as you can see there, police or law enforcement agency would use this information to sort of enforce security. Right? So the question now is, we have so much data, right? We have so much data with so many different devices, so many different types of communication. So how do we support them, right? How do we facilitate this communication, right? We need to think that network basically it's the fundamental enabler for all of these, for IoT. So if you can do a lot of smart things, right, but you can't communicate to the other side of the system, then there is basically no point of doing that, right? But also just to keep in mind that networks are changing too, right? So connection is getting faster, like with 4G and 5G, right? Latency is getting lower. We have more reliability, more bandwidth, more capacity. So more nodes, more connections, and you have these really specific IoT protocols like 6LoWPAN, MQTT, right? And also using IPv6 to address things because we just have too many devices, right? So IPv4, we're running out of IPv4 addresses. So IPv6 addresses are used for IoT systems when they want to communicate over the internet, right? So you need really specific protocols to sort of facilitate this communication. And if you think about it, IoT, it's basically these nodes can reside at any time, at any place, and it can be anything, right? So it's not just a computer like on the internet, right? So it can be anything from sensors to something on your mobile phone, right? Or something that it's like a motion sensor or anything like that. Again, machine-to-machine Internet of Things. I have billions of interconnected devices, and everybody is connected. Then you want some form of communication technology to bring them together. So a lot of work, research, development are done in this area, basically networking and communications, to make the networks smarter, right? To make the networks more intelligent. So it's just not something that you send the data across, right? So it's not just a piece of equipment that forwards packets, right? You want these networks to be smart, right? To adjust according to the network load, to do some data centric and content oriented networking, right? Depending on the data, depending on the content. So there's a lot of work going on in this area now. And there's also this thing called context-aware autonomous systems, right? So a system that is aware of its context, that is aware of what's happening around the area. So we don't respond to a set of circumstances the same as the other, right? So if you are encountering circumstances or situation A and situation B, the same system would make different decisions, right? So if we can design systems like this, then we can basically save on resources, on cost, and make more informed decisions. So here is sort of the diagram that captures the different layers of the Internet of Things. In networking, we talk about the OSI layer, right? So you have the 5-layer and the 7-layer interface, but this layer is slightly different. This is more from a system level. And if you read lots of different papers and research in the area, different people propose a slightly different variation of this layering architecture, right? But this is sort of a generic categorization of the area. So at the very bottom, you have this layer called things, right? Or this is where your sensors, actuators, your hardware, your devices are categorized, right? So things, and they talk to devices, right? So these devices can be intermediate gateways that do some form of processing, right? And then you have the communication layer, which runs all these different communication technology, right? So like LoRa, MQTT, 6LoWPAN, all of these, Zigbee, right? Z-Wave, all of this IoT technology that runs at this layer. And a lot of this interact with our internet traffic too. So basically, if you use like 5G or 4G or a broadband network, then you sort of interact with the internet. And the next layer, it's the cloud infrastructure. So we talk about the cloud infrastructure like AWS, Google, or Amazon, like Microsoft Azure, etc. This is where like powerful computers are, right? So powerful resources, right? So cloud computing basically sits in the cloud infrastructure layer. And after that, basically, is the service and application layer. So depending on what the company or the enterprise wants to do with these systems, then they form that layer, right? And also users, right? Users like you and me, we're just regular users of IoT. Then we are part of that application users layer, right? So this is a form of a large sort of overview of the layering architecture in Internet of Things. It gets more and more complicated now because we just have more and more devices, more and more services, and a lot of these services are cross-cutting in layers. So we need to just have that mental model of how IoT are categorized. So IoT is not just basically one system that captures everything, right? So you have this interaction between different layers of devices. So this is a slide that shows the evolution of mobile communication technology. So technologies change every 10 years in mobile communication. That's roughly the time where you see a new generation of communication technology, right? So 1G back in 1980s, when there's only analog signal and voice data. Then you go to 2G in the 1990s with data, but low data. So GSM, GPRS, CDMA technology comes to play in the 1990s, and you can see the smartphones getting smaller. And then you have 3G in the 2000s, right? So that's when the iPhones, the smartphones comes to play, a higher data rate, more IP communication capability with 3G. And then for the past 10 years, 4G is driving the innovation in the technology sector, right? So a lot higher bandwidth capacity. A lot of people have like smartphones and use smartphones to do all sorts of bandwidth intensive application like streaming YouTube or watching like streaming movie online in the car, in the train, etc. When you're moving, right? So this is not possible before just because you didn't have that capacity, and bandwidth is really expensive. So 4G is a lot more possible with LTE, so long-term evolution, and a lot of people have really expanded in that 10 years of 4G. So text, data, voice, they're all over IP. So basically, you route everything over the internet, right? So over the internet infrastructure. And starting from so that's basically in 2010s, right? So 4G is 2010s, and then 5G it's basically 2020. We are at the beginning of 5G now, and from 4G to 5G, it's a huge leap in the sense that we are not just concerned about sending data, sending text, sending video messages, video calls, right? We don't want just to have more of something, right? We want to have more of the applications, right? So more use cases in 5G. So 5G, we talk a lot about IoT, talk a lot about AI, machine learning, industrial IoT, automation, smart vehicles, smart cities, right? So in 5G, mobile communication technologies are no longer used for mobile communication only, right? So it's not just between smartphones or tablets, right? It really expanded its area into this smart city smart industry, smart vehicles concept, right? So 5G is there, and it is still under active deployment. In some countries there are more higher deployment than others, but it is progressively being rolled out as research is underway. Right. So in the next 10 years, people are working on 6G. Right. So every 10 years, you see that leap in technology, and a lot can come out, right, in that 10 years. Right. Standardization, process improvements in technology, and all this innovation can really bring that generation of communication forward. So in 5G, people talk a lot about like URLLC, right? So ultra reliable, low latency communication, which is very important for latency sensitive or mission critical application. So that's one of the attractiveness of 5G, but it is yet to be seen of how solid that performance is, right? Because we're still at the start of deploying 5G. So just to quickly summarize the loop of our IoT, right? So we talk about having this constant loop of our IoT. It is actually quite simple in the sense that you can categorize this loop in 3 processes, right? You have sense, think, and act. Or sense, it's basically the senses, right? Sensing technology, collecting data. So for example, you have a temperature data, you collect data, right? So you collect temperature data. Think, you will send this to the cloud or to a gateway and process the data, right? So I have a bunch of sensor temperature data. What do I want to get out of this, right? And maybe you just do a simple loop, right? So for example, if it's more than 30 degrees, turn on the air conditioning, or if it's less than 30 degrees, turn off the air conditioning, right? So that's your sort of process. Then you send the information to your actuator, right? Your sensors that basically turn on and off the air conditioning, right? So you, if it's more than 30 degrees, I send a command to my actuator saying turn on the air conditioning, and then it will turn on its air conditioning, right? And then depending on the environment, the sensors collect the data and send it to process, to think, and then it might make a decision to turn off the air conditioning, etc. So you are constantly in this loop. The air conditioning temperature sensor is just a very simple example, but in a lot of complex IoT systems, that's basically the process, right? So sensing, processing, basically thinking, and acting, right? So that 3 sort of stage loop. So here is an example, just an example of smart CCTV cameras, right? So video cameras are increasingly used in many public and private areas, like our homes, our shopping centers, car parks, parking lots, etc. And usually this data collected by CCTV are uploaded to a data center, right? So you can't really store too much data on the smart camera itself, right? So what would you do, right? Would you capture the smart camera in HD and send it to the cloud? Probably not, right? So you don't need HD video to determine whether something has happened, an event has happened, right? Because HD video consume a lot of storage space and also a lot of bandwidth, and takes more time to upload to the data center. Right. So what you would do is you basically you would use some machine learning AI image processing algorithms. You basically filter out, right, the unnecessary or unnecessary information in the image or in the video, right? So say for example, in this case, you can automatically detect and track people, right? So you can automatically detect and predict various anomalies, right? So you build this model to basically track people moving around, and can detect emergencies, right? So for example, in a home, if a disabled or elderly person fell down, this algorithm can pick it up, right? So there's some emergency, we need to do something about it, or there's a theft in a parking lot, right? So there's some anomaly there. It will pick it up and make the decision and inform the authorities, for example, right? So yeah, in this case, the bandwidth of visual data, it's very inefficient, right? So you don't want to send HD video to the cloud 24 hours or 7 days a week, 365 days a year, right? So they would consume a lot of storage space and a lot of bandwidth, right? And it takes longer, which means that you won't get the information back as quickly, right? So you will do this filtering of data and to do some real-time monitoring and detection of anomalies, right? So if you have a bounded latency requirement, say I need my decision in 10 seconds, right? Within 10 seconds, you need to basically give me a decision. Then these algorithms will quickly work out, filter out unnecessary data, do some processing, and within 10 seconds, hopefully, it will return a result, right? So timeliness is very important in a lot of these image processing and IoT sensing system. So IoT is data driven. So by now you can see how much data is being generated by IoT devices. They create data at an exponentially growing rate, and it will drive performance and network congestion challenges at the edge of infrastructure, right? So if you pump out a lot of data, a lot of useless data, then you basically overwhelm the network, right? And affect other people's connectivity. So there's different performance metrics like security, bandwidth, reliability, many concerns that actually make cloud-only solutions impractical, right? So imagine if you want to send every bit of information to AWS, for example, that's quite impractical, right? And it's expensive to do that. So a lot of current IoT technologies do some analytics at the edge or at the device level itself and filter data before it goes to the cloud. And usually you would connect to the cloud because that's the connection there over the internet, but you won't use it all the time for every single bit of data, right? Because that's really impractical. So this slide summarizes, right, the situation we are in. If this is just too much data, right? So if we send everything to the cloud, as you can see, there are many different sensors, many different devices. If we send everything to the cloud, then there's basically too much data, right? Latency is too high, right? You're congesting the links. Back to that example of CCTV sending all of the information to the cloud, right? Transport cost is too high as well, right? So that's bandwidth issues, resiliency impractical, right? So what happens if your link fail, right? So if your link to the cloud fail, then your whole system basically goes down, right? So is that what business want? Probably not, right? You want some form of redundancy and resiliency in your enterprise, in your business. So there's some issues related to IoT relying on the cloud only. So IoT, cloud computing, and big data. So by now you will see how three of these are quite tightly linked, right? So the Internet of Things collects lots of data, right? And big data helps us to analyze this data, make decisions using AI, machine learning, algorithms to process this data, right? And how do they process this data? Usually they do it in the cloud, right? Because in the cloud, they have more resources and more powerful servers to do such large amount of processing. And after you do that processing, you return a decision, you send it back to the IoT actuator to perform that decision. So you can see how tightly interconnected these three fields are in today's world. So IoT, big data, and cloud computing, there's this intersection in the middle there. And of course, you have at the edges, you have very specific cloud computing, research and development, very specific big data analytics, right? So I think people do mathematical modeling, graph analysis, work in big data, and they don't really think about IoT and cloud computing, right? So at the edges of big data in IoT as well, right? So you have people working on very specific IoT algorithms to communicate, right, over the network. So embedded systems and all of that. But three of these fields are tightly interconnected, right? So for IoT to work, you need these three components. So this is to summarize that, yeah, cloud-only architecture approaches cannot sustain the projected data velocity and volume requirements of IoT, right? So back to that picture, if we rely on the cloud only, then there's going to be a lot of issues, right? Cloud is great, cloud computing, it's a revolutionary paradigm, but we want to have that resiliency and flexibility in our systems, right? So our IoT architecture shouldn't just rely on the cloud, right? So imagine you have hundreds of thousands and millions of devices be organized in a way that have this nice architecture, right? Not just relying on the cloud only. So that's the architecture that a lot of us are working towards. So in businesses, enterprises, research and development, they work towards this what they call the N-tier deployment architecture, right? So this layering architecture. So rather than having sensors and actuators connecting directly to the cloud, you have these sensors and actuators connecting to the edge node, right? So the edge node is basically, say for example, a Raspberry Pi or some intermediate device that do some data acquisition, collection, preparation, right, or filtering of the data. And that gets passed on to the next layer, which is the fog node, right? So the fog node has higher capacity power, so it can do some critical real-time or near real-time processing, right? So it's a more higher level machine, right? So once the decision is made, then it can return to the actuator, right? So it doesn't need to pass on to the next node. So the highest node is the cloud node. So that's where again, that's the huge data center, AWS, Google, and Microsoft are, right? So remote cloud. So a lot of the times we don't need to send the data all the way to the cloud, right? You can send it to the edge. If the edge can process it, fine, return the decision back to the actuator. If the edge can process it, send it to the fog node, and the fog node can process it and return it back to the actuator, right? So you probably heard about the term edge computing, and fog computing and cloud computing, right? So that's basically the different layers that we sit. So edge computing is very much an important area, because if you do computation at the edge, that means you are closer to the nodes, right? If you are closer, that means the latency is lower. If the latency is lower, it means that you can get your decision in real time, right? So near real time at least. So there's all of these different considerations depending on what you are trying to do with your IoT application. So if you're interested, you encourage you to look into these paradigms, right? Edge computing, fog computing, and cloud computing. So that's basically what it looks like, right? The three-tier architecture, right? So sensors and actuators are hardware devices. You connect to the edge tier, which is millions of nodes, right? And they are connected, aggregated towards the fog tier. The fog tier gets aggregated and connected to the cloud tier, right? Thousands of nodes. So fog tier can be quite powerful, right? They can be like our internal data center or internal service, right? So as you can see, as you go up the hierarchy, the number of nodes, the number of devices reduces, right? So you have less and less devices as you move up the hierarchy. But as you move up the hierarchy, you have less data as well, right? Because data is being filtered at every layer, right? But what you get from this filtered data is you have more information and more insights, right? So that's what it looks like in the three-tier IoT architecture, right? So as you go up the hierarchy, your volume decreases, right? You have less and less data because you filter at each layer, but your analytics actually increase, right? You get more and more powerful algorithms, you get more and more powerful computation as you move up the tier. So hopefully by the time it reaches a certain point, you have enough processing power to process the data that you have collected, and you can make informed decision. So that's the whole sort of IoT architecture that people are working towards. And if you are working on some specific prototype, a specific project, you are probably familiar with this idea. So if you're not familiar, that you're probably working already on such an architecture, but that's just some sort of idea or theoretical sort of grounding for why we are doing this type of IoT architectural design, right? So the whole idea is we want to balance the requirements and also the processing ability, right? So if you want better performance, you want to go up to the cloud. But if you want low latency or near real-time processing, then you don't want to go all the way up to the cloud, right? So how do we balance these two considerations? All right. So that's it for my presentation and my lecture today. I'm happy to take any questions. Feel free to ask if you have any questions, or if you would like to share some interesting insights from either your work or your studies. I'm happy to interact with you all. Yeah, thanks.
Okay, thank you, Dr. Hua, for your presentation. Students, any questions? I think you can type in the Q&A session or section, or you can raise your hand so we can unmute you. Okay, I see Dio Damar. Okay, Dio, we have unmute. You can unmute yourself and ask the question.
Does the robot use
Dio? Yes, feel free to ask your question, Dio.
does the robot uses the Internet of Things?
Does the robots use Internet of Things?
Robot.
Yeah,
Okay.
Thanks, Dio, for your question. Very good question. So, robots is part of the interconnected ecosystem, right? So you can say robot is part of the thing, right? Because robots they are basically equipped with sensors and actuators, and a lot of them have a connection to the internet, right? Or at least have like Bluetooth connection or connection to a central a gateway. So you're absolutely correct. Robots and all of this automated machinery are considered as part of the Internet of Things. So there's this whole field called robotics Internet of Things as well. So very specialized field that's targeted of using IoT in robotics. Yeah. So
Okay.
I see there are some question in the chat.
Yes.
Should I answer?
Yeah, I think there's a question from Samuel. How about the security for IoT items? Has the internet always had a bad side, hacker, etc.? How did IoT items encounter those hacking and data loss for its users?
Yeah, very good question, Samuel. Yeah, thanks for your question. And again, there's this whole concern about IoT security, right? Because a lot of people, when you buy a sensor, when you buy a device, if you buy 100,000 of them, you don't want to change the password for each of them, right? So that's why a lot of people don't really bother to change that password, which is a bad idea because a lot of these devices actually are not very secure. So yes, it is a concern, and a lot of people are working in that area of encrypting and applying lightweight cryptography to IoT data. We don't want to apply like a full-on cryptography in IoT, right? So you don't want to do really intensive cryptography like on the computer because it takes a long time to process it and decrypt it. So people design lightweight authentication security mechanisms for IoT. And certainly a lot of them are not unsurprisingly similar to what we use on our daily devices which we communicate over the internet, right? So similar principles, but at a more lightweight fashion, right? So that's so true, and it is entirely possible, right, for IoT devices to be hacked, and it is quite bad when it happens because you're dealing with a large number of the devices in the business. Yeah, thanks, Samuel. Yeah.
Thank you, Dr. Kwa. Another question is from Gregorius Albert. I would like to ask about IoT edge devices can be placed in offshore or remote locations where internet or GSM speed might be very low and unstable. That might affect in using simpler data transmission protocols to reduce data transfer size, and how to make sure that the data transmission will be secure while using a simpler data transmission protocol.
Yeah, thanks, Gregorius, for your question. That's a very good question too. So in terms of security, that's sort of the idea, right? So when you have simpler transmission protocols or simple connection technology, usually you compromise on the security aspect. So I'm not sure if you heard of the MQTT technology. So MQTT, it's very simple, right? Very lightweight. It's plain text, right? It's literally plain text. Like you can see what's in the message. So there's an example of how lightweight protocols can compromise on security. But then a lot of people run MQTT over secure channels, so that solves the problem. Right, so you run encryption over the channel, and that's fine. About your question on IoT edge devices in remote location, that's a very good question. So there's this a lot of projects like in Australia, because Australia is so big and it's just impossible to have high-speed connections or very good connectivity in a lot of areas. So a lot of these areas would have they call infrastructureless service, right? So you have this self-contained like a small ISP data center that service that area, self-contained, which means IoT devices will interact with that gateway directly without having to go all the way to base station, etc. So yes, a lot of issues there, and that's a really good question, because how do we provide a good coverage of a wide area, right, with IoT when if we just rely on, say, 4G or 5G, right? So, and one of the ideas of 5G is to have that huge coverage, right? So, yeah, we'll see how that pans out, right, with in terms of 5G. But definitely a good question, and we want everyone to have access to the internet, right? And that's the pandemic really proves how important that is. Doesn't matter if we live in a city or in a smaller town, right? So good internet connection, it's very important today. So yeah, so hope that answers your question.
I think that also answers the question from Nathaniel. And so we will be moving on to the question from William. How can we balance the confidentiality, integrity, and security aspects in IoT?
Yeah, so very good question too. So yeah, so the CIA triad, it's the sort of this cornerstone of security, right? So confidentiality, integrity, and availability, right? So it's the same, right? It's the same in IoT. We want data to be confidential, right? So for example, not ASIN's data to not be. We want to ensure that that's the only channel that they communicate with. Data integrity, if not ASIN's data to not be not can't decrypt it, right? So we want, or even if it changes it has to be detected, right? So this is we need to really balance that, and that's part of the security mechanisms being deployed in IoT, right? So a lot of IoT communication protocols have this inbuilt communication systems that basically ensure the confidentiality, integrity, availability of IoT.
Yeah. Okay, thank you. Yep. And next question is from Visra. Do you think IoT with AI can be made to quickly detect someone's fear when in danger?
Oh, yeah,
interesting question, isn't it?
Yeah, very interesting question. And very good application too, right? So, yeah, I mean, it's just with AI now, like people work in AI to detect all sorts of things, right? So it wouldn't be surprising that they were able to detect people's emotion. And there's already a lot of work going on with facial recognition and detecting people's emotion, right? Whether people it's fearful, angry, or sad, right? They can be detected. And now with the pandemic, a lot of AI systems help with determining if people is wearing a mask or if they are social distancing, etc. So yeah, it's definitely possible. But yeah, I haven't heard much, or maybe there's already implementation of this. But certainly, it's yeah, it's very interesting.
Next question is from Christopher. It's regarding the future. Do you think we will ever run out of storage space in the cloud in the near future? What will be the solution if, let's say, one day it happened? Will the IoT devices become useless then?
Yeah, thanks, Christopher. Thanks for your question. Yeah, interesting question too. Will we ever run out of storage space? I mean, it's when we say cloud, right? People also say cloud has unlimited resources, right? But we all know it's limited, but it's only unlimited from the perspective of the device, right? Because we don't need that much capacity. So in terms of will we ever run out? Yeah, it's a tough question to answer because we'll just build more space, right? We'll just build more hardware for this storage space. It's not like it's IPv4, for example, right? So IPv4 has a finite space, right? So once it's run out, it's run out. You can't invent more addresses, right? Whereas storage space, if you use up, you can build more, right? Capacity for storage, or basically reduce the amount of information or data in the current system. So I think to answer that question, storage space will only run out if, say, we can't build anymore, right? That's there will be that question. And will they become useless if that ever happens? So IoT devices, like any other internet connected devices, right, we need storage, right? So if we can't store data, then it is not, we can't really function as intended, right?
Yeah. I'm moving to the questions in the chat room just to combine it. There's a question: if cloud isn't powerful enough to handle IoT device, then can we eliminate cloud and only use Fog node to handle it? How to decide how many Fog node we need?
Yeah, so that's a good question. So depending on the requirements of your system, right, and depending on the fork node itself. So if the fork node is very powerful, then it might be suitable just to run your algorithm on the fork node, right, without sending to the cloud. And in terms of how many, that again depends on the service that you want to provide for your IoT service, right? So really depends on the application itself, right? But it's entirely possible to do that. Yeah.
Okay. Another question: is it possible to reduce IoT device production costs so more people can apply IoT device in daily life? What would be the drawback of the reduced cost for the production?
Yeah. So that's a good question too. And yes, it is. The cost has come down quite a lot over the past 5 to 10 years, right? So, if you go on online, you can buy embedded devices quite at a reasonable price. So it has gone down, and in terms of its compromise, it is trade-off. Like any other things, right? So if you go cheaper materials, then you get like a less quality product. But we want to ensure that it is still functioning as intended, right? So no security loopholes, right? So as we drive down the cost, there is a possibility of that compromise as well, right? So in terms of hardware, in terms of security, right?
Yeah. So Dr. Hua, I see there was a student, Henry Hamilton. You raise your hand, so
Yep.
You can unmute yourself now to directly ask the question.
Oh, yes, hello.
Hi, Henry.
Yeah.
So I actually written this in the chat window also. So I wanted to talk about what happens when there's a disconnection or failure, because a lot of devices that utilize Internet of Things tend to become non-functional when they're not connected to the internet. Yeah, for example, you got during the Google outage some time ago. Yeah, you get a lot of people getting stuck in their homes, being locked out, or they can't turn their lights on or off, stuff like that. So, yeah. So I want to ask, how would you think in the future that IoT can handle this kind of internet failure?
Yeah, I mean, thanks, Henry, for the question. And yeah, it happens more often than we thought, right? Like, if a major service goes down, then a really simple operation just can't work. Like you said, can't turn your lights on and off because internet's not working, right? So we don't want to be in that situation. And unfortunately, a lot of solutions today really depends on the internet, and that's why I think in that slide there we have that one, right? That impractical resiliency, right? So that it's an important block because, like you mentioned, Henry, if the link goes down to the internet, then a lot of the really mundane or really basic functions can perform. not because they can't, it's just because they rely on the cloud, right?
Mm-hmm.
So the solution to that is to at least have an edge tier, right? So an edge tier to process the data, or to make some local decisions, like for really mundane or basic sort of decision, right? So if you have a smart home, then hopefully you can build you can install a gateway locally that doesn't rely on the internet, right? So that still can be operative. Of course, if you want to turn it on and off from another location, then it's impossible, because you need to rely on internet connection to do that. Yeah. So I mean, that's definitely an area that people are working towards as well, not to be over reliant on service providers, right, on internet. Yeah. Thanks, Henry.
All right. Thank you.
Okay, thank you. So there's another question here. I see that how about the personal safety, including personal relation, when implementing IoT, like the act of doxing, hacking, puppet, and etc.
So I'm trying to find a question. Is that?
Yeah. I think it's regarding the security probably, and privacy probably.
Okay. Is that in the chat, Santi? Sorry.
Yeah, in the chat.
Okay, let me just.
The act of
I'm just looking at two windows.
Yeah.
Okay. Yeah, I found it. Yeah, personal safety. How personal include relation? Yeah. Personal safety. So yeah, that goes back to the security question as well, right? So I think your question is more of what happens if the IoT actuator it's not performing like what we instruct it to do, right? So I mean that's a problem, right? So that's a problem of the system itself, right? So if the IoT system makes its own decision, and that's a lot of people are worried about, right, with AI and machine learning, of these systems making their own decision and harming the owner or harming the user, right? So personal safety in terms of that, and that comes down to ethics, right? Ethics in implementing these algorithms. That's definitely a valid concern.
Yeah, and there's another question. This is a very important, interesting one. Will IoT can also be connected to human? As an example, smart organ, heart, lungs, and etc.
Yeah, very interesting. Yeah, smart organ. Yeah, interesting. I haven't really come across this. I mean, people have implanted chips, right, in the body. So like pacemakers and all these devices in the body, and yeah, I don't know if you want your heartbeat or your information of your heartbeat to be connected to the internet. That's and people can do something to you over the internet. That's not great, right? So that's probably it's not the question about whether it's possible. It's more of, if it's ethical or not. If it's ethical not to do such a thing, yeah.
And I think they have tools to, if I'm not mistaken, to detect your blood sugar level continuously. I forgot the name. I came across an article a few days ago, but you can. It basically like a chip probably installed in your arms, and then you can see the results through a mobile application, if I'm not mistaken.
Oh, right. Yeah. I can imagine that happening. Because now we have all of these wearables, like devices, sensing sort of blood pressure, sugar level, and all of this heartbeat. But if it's installed directly in human, then that's more concern.
One is for the type 1 diabetes, I think.
Yeah, that's right. Because you don't want IoT to be installed in a way that people can control, right, what happens in the body. So that's not good.
Yeah. If we see there's more questions, Dr. Kwa, I think this is a you have a very you have a lot of questions here.
A lot of questions. Very
yeah,
good.
I'm quite surprised as well. The students are
Right.
very active. So must be
Very
like
good.
the topic is interesting for them, right?
Yeah, I'm really glad. Yeah, really glad this opens up all this conversation. Yeah, it's good to see all these questions coming in.
Yeah. So there's a question from Reinhard. Does the algorithmic cost of performing encryptions pose a challenge in creating embedded devices which can securely process and transfer collected data? It's in the Q&A.
Yeah, yes. So thanks, Andy. Thanks, Reinhard, for your question. And yeah, definitely, it's there's always cost, right, to perform encryptions in devices. So depends on how complex you want your security to be. So in security policies, they always talk about this idea of this trade-off, right? So this trade-off of, say, for example, if all of your data is being compromised, right, you lost X dollars, right? But if you implement a security mechanism, then you will need 10 times X dollars, right? So would you rather implement 10X dollars, or would you rather take the risk and lose X dollars, right? So there's that trade-off between whether you want it to be really secure, or if you want really real-time performance of your device, right? So bear in mind, in IoT, a lot of times we value timeliness in data, right? We want data to be processed as quick as possible, because if data is processed late, then that data is useless, right? So we're already past the deadline and we don't need to know that information anymore. So yeah, definitely an interesting question. And there's a lot of work going on to how can we do the encryption and security mechanisms as secure, as quick as possible. Yeah.
Yep. Okay. Another question from Johannes. Is it important to use AMQP service in IoT implementation? For example, like MQTT broker for communication between service or device. Does using Q service have any impact in security?
Yeah, thanks for that question, Johannes. So yes, MQTT is being used very widely, right? So if you go to, say, the IoT Eclipse MQTT broker, you will see lots and lots of devices being connected to that MQTT broker, and you can see live actually of the number of messages being stored in the MQTT broker, right? So in MQTT, you basically have this publisher and this subscriber, right? So the publisher publish the topic under specific hierarchy, and your subscriber subscribe to that topic. So once the publisher publish data, all the subscriber under that topic will receive that update or the information. So MQTT, it's more popular than AMQP. I would say it's more well accepted. They're very similar in terms of how they perform, right? So AMQP and MQTT, they're all application layer protocol. So they operate on top of transport layer protocol, and very simple, lightweight, but very efficient, right? So I think you have that question about, does using queue service have any impact on security? So not so much on the queue itself, it's just the whole protocol, right? So if you run it over a secure channel, that's fine. If you run AMQP or MQTT over a secure channel, that's okay. It wouldn't have any impact on its security. So people use MQTT for updates, right? So updates, if say I want to update 10,000 people or 10,000 nodes, right? I will just publish to the broker, and the broker will broadcast to 10,000 subscribers, etc. Yeah. So yeah.
So another question: the new technology, Neuralink, Elon Musk. Yeah, what do you think about it in terms of IoT?
Yeah, good question, Billy. So, I mean, this is basically on the basically pushing the boundaries, right, of what technology is capable of. So, you want to build this Neuralink type technology where you interface brain and machines, right? So, there's a lot of work going on in that area, and it's definitely part of IoT and AI and machine learning and all of that mixed together, right? But here we're talking about more sensitive information, right? So a very, very sensitive information say from between the brain and the machine, right? And how do you convert that into signals, right, in IoT? So yeah, certainly very interesting. And remember, IoT it's not a product, right? It's not like it's not, say for example, like a model of phone, right? IoT is not a product. IoT is an ecosystem, so it is always expanding, right? It can include all of these new technologies like it's upcoming, right? So Neuralink it definitely falls under that category, like upcoming technology, and IoT. And IoT is a system because anything that are interconnected with each other or connected to the internet, they basically forms that ecosystem of IoT, right? So I would say, yeah, Neuralink it's that upcoming, like pushing the boundaries of technology, and yeah, it would be interesting to see what comes up from that work.
Mhm. Okay. So another question about is like, what is your opinion about decentralized IoT data, like using blockchain?
Yeah. So yeah, the blockchain is another hot area that it's more towards the big data area though, like blockchain and security. But it operates on IoT data as well, right? So, like you said, Gregory, is about decentralizing IoT data, right? But most of the times we don't need to do that because IoT data it's not super important data, right? It's not you don't need this data to be super secure, like Bitcoin or this financial cryptocurrencies information, right? Because again, blockchain you have this decentralized infrastructure, which is great for secure systems. If you want a system to be really secure, then you will use blockchain to do that decentralized management mechanisms. But in terms of IoT data, there's also work on using blockchain, but not like the top priority of using blockchain because of its consideration, right? So people use blockchain in big data, in security, in cryptocurrencies, more than IoT. Yeah.
Okay. So I will switch to the one in the chat box. Is IoT can be implemented without using big data technology?
Yeah, thanks, William, for that question. So, yeah, it can be implemented without big data technology. Big data, it's basically a collection of technology for processing data, right? And again, as we've mentioned in the lecture, that we need some form of mechanism to process the data, right? Otherwise, there's no point of collecting the data, right? If we don't process and make some decisions or get something useful out of the data, right? So, I mean, it can be processed without big data technology, but you still need some form of data analysis going on there. Big data is just a term that's like a collection of algorithms to process large amount of data, right?
Yeah. Another question from Anizo. What is your opinion about the Tesla autopilot system? Is it already a perfect program? Would be nice if we can have a try, isn't it?
Yeah. So it's interesting question. Yeah, I don't know too much about the Tesla autopilot systems, unfortunately. But yeah, auto driving systems, autonomous vehicles. Yeah, they are part of the 5G IoT era. So if you like, they're part of the autonomous vehicles, and the Tesla autopilot system, they will definitely have sensors that communicate right between like vehicles and to the infrastructure, etc. Yeah, I'm not sure whether it's a perfect system or they need some development. Yeah, but I'm sure it's Tesla is working on a lot of exciting projects. Yeah.
Yeah. Okay. So I think because like we're almost running out of time, the students that might not be aware now is our almost 9:30 for Dr. Phua in Melbourne, so it's really late at night. So probably one last question from me, Dr. Phua, because like most of the students here are like final year students, and they will be like doing the final project thesis in the upcoming semester, do you have any recommendation on how they can, let's say, create an idea for an IoT project for their their thesis?
Yeah, good question. I think I saw some question on that too, whether it's expensive. I think Kevin has a question on making IoT project, and I think Amelia has a question on TCP/IP and MQTT technology and privacy, neural networks communication. So just want to sum up. Yeah, it's really good to see all of you really excited in this area. So definitely a lot of opportunities in this area, whether it's research or implementation or jobs. So in terms of how to come up with an idea for your thesis, for your project, look into what are the avenues, right, in this area. Say for example, I think there's a lot of question today about security and privacy, and that's rightfully so, because we're concerned about security and privacy. So there's a lot of ideas in that space, right? Security and privacy of IoT, because there's a lot of attacks that happen from IoT, right? So that's certainly an idea for your thesis project if you're interested in security and privacy in IoT. In terms of the communication aspect, there's a lot of work in communication, right? So how do we have a better communication technology or framework for such a large or diverse range of devices, right? So again, there's millions of different devices. How do we determine what communication technology to use, when to use it, and what are the performance, right? And there's also ideas on power consumption, right? So if you use protocol A versus protocol B, they all perform the same, but in terms of power performance, what is it like, right? So say if you have 10,000 sensors in your agricultural farm, 10,000 sensors, you don't want to change the battery every year, right? That's a lot of work, right? To change 10,000 batteries every year. So you want it to last at least 5 to 10 years. So things like that. There's also work in, say, industrial IoT automation, right? So industrial IoT automation, how all of this, like robotics, I think there's a question on robotics, right? How does robotics make use of IoT to deliver good service? So yeah, that's a lot of opportunities, but yeah, to summarize, to put in a summary, you can look at the application aspect, right? So use cases, application, the connectivity, the communication technology, and also the security and privacy area. Yes, to give you some ideas.
Yeah, thank you so much, Dr. Kwa. For the students, I just put an information about the Deakin Hackathon, Deakin AI Hackathon. Yeah. So I posted the information about the hackathon around more than 2 weeks ago in your group. I just want to remind that the registration deadline is tomorrow, the 17th of August 2021. So please do check again on this event. If you missed my the information that I posted in the group, I will post it again by today. Yeah, I will repost it again. But for those of you who are already aware of it, please don't forget to continue to register yourself, because the deadline is tomorrow. It is an amazing opportunity for you to exhibit your knowledge and also your skills. And it's an international event. Of course, on top of the prize, it will be very much appreciated, especially if you put it in your CV, right? So don't miss the event. Yeah. Okay. So Dr. Kwa, thank you very much for the session and also for answering the questions. This is one of if it's not the seminar with most questions that I've posted so far.
Yeah, thank you very much, Santi, for the invitation, and to Susan for organizing, and appreciate this opportunity, and to all the students too. It's been a really great time, a pleasure to be able to interact with you with your questions. Feel free to yeah, do some more research and experimentation in this area. It's a huge area with all these new technologies coming out like AI, machine learning, IoT. So yeah, really wishing you all the best with your studies and also your internship and your future careers as well.
Yes.
Yeah.
Thank you so much for your time and have a good evening, Dr. Kwa.
Yeah,
We
thanks.
hope to
Thanks.
see you in another event.
Yeah, we're looking forward to seeing you all next time. Yeah, thanks,
Yeah.
Santi. Thanks, everyone.
Stay
Yeah.
healthy. Bye.
Bye. Have a good night. Bye-bye.
For the students, I will be sharing the screen for the attendance list. Please bear with me for a while. Yeah. So please fill in your attendance as soon as possible. I think it's only going to be open for the next like 10 minutes or so. Okay, so thank you very much for joining the seminar today and also your like active participations in giving questions as well. So I'm very pleased seeing your questions and especially like the quality of the questions are very good. And yeah, same like Dr. Kwa has mentioned, I wish you good luck in your projects, in your future projects. And feel free to consult with the faculty members directly if you have any ideas about like the IoT projects in Jurusan. We have quite extensive range of devices as well, although since this is like during the pandemic time, we are not really sure on how to manage it like the devices physically. But yeah, please contact the faculty members in each campuses, the one in Jakarta, Bandung, or Malang, if there is a possibility in using those devices for your projects. Okay, so thank you very much, everyone. Have a good evening and stay healthy, everyone. Bye.
Terima kasih Bu Santi.
Thank you, Bu.
Yes, I want to ask, what is hackathon?
Apa nih?
Apa itu hackathon?
Oh, lomba, Dio. Itu lomba hackathon. Basically ada seminarnya, terus ada lombanya juga. Kamu baca deh di linknya itu. Jadi kalau kamu lain kali dengar hackathon itu istilah untuk competition gitu ya. Cuma competitionnya itu ada yang misalnya nih seharian semalam suntuk 24 jam ngerjain ada. Ada juga yang sifatnya dalam seminggu gitu dikasih waktu ada. Jadi variasinya macam-macam. Nah, pastinya kamu cek linknya ya. Yang di chat meet saya udah masuk. Ya.
Terima kasih
Ya.
Bu Santi.